Okay, in this video we're going to be looking at how to solve quadratics over the complex interval. So let's have a look at the first one over here. For the first one over here, we're going to solve it like any other equation we normally would. So z squared, and then we can minus 4 from both sides. And if we do that, what we get is z squared equals minus 4. And then we can square root both sides. So that means z is the same as the square root of negative 4. And that's the same as negative 2. So that's our solution here. Let's move on to the next one. Wrong. Okay, you cannot do that because you are not allowed to square root negative numbers over the real interval. So what do we do here? Well, what we can do is we can first employ our distributive law inside the surd. So we can say negative 4 is really just the same as 4 times negative 1. And if you multiply two numbers inside of a surd, then you can really just multiply both those surds separately. So this is the same as square root of 4 times the square root of negative 1. And we know that the square root of 4 is really just plus or minus 2. And the square root of negative 1, that's really just the same as I, because this is our imaginary number. Okay, I is the same as the square root of negative 1. So now we can employ that the solutions to this equation which work are plus or minus of 2i. So let's have a look at the next question. The next question is 2z squared plus 18 equals 0. So now we're going to do the exact same thing we did before. Solve it like any other normal equation. So I'm going to first divide both sides by 2. And what I get is z squared plus 9 equals 0. Minus 9 to both sides. And then I'm going to square root both sides. Remembering this time that I can't just square root negative 9. So if I want to square root a negative number, I can simply just write it as plus or minus 3. Because that's the square root of 9, and then add an I next to it, because the square root of negative 1 is really just the same as I. So this is a solution to this equation here. And then our last equation is this one here. Solve z plus 1 whole squared plus 49 equals to 0. So again, let's solve it like a normal equation. Okay, we can first minus 49 to both sides. So z plus 1 whole squared equals to negative 49. And that means that we can square root both sides to say that we have z plus 1 on this side, and that's the same as the square root of negative 49. Well, the square root of 49 is simply just plus or minus 7, but then because we're square rooting the negative of 49, we can simply just add an I. So now if we want to solve for z, we can minus 1 from both sides, so we get negative 1 plus or minus 7i. So our two solutions are z1 equals negative 1 plus 7i, and the second solution, z2, is negative 1 take 7i. And that is how you solve these equations over the complex plane. Okay, let's have a look at these 5 questions here. We're going to solve these regular quadratics. Okay, we're going to solve them over the complex plane. And I'm going to tell you straight away, none of these quadratics will have pure real solutions. They will not have two real solutions. And that's just to save you from trying to do splitting the middle term, completing the square, or even using the quadratic formula. So what do we do in this case? Well, what we need to recognize is, let's look at the discriminant for each of these equations as we do them one by one and check to really see if they have any real solutions. So let's look at the first one. The discriminant, for those of you that don't remember, is b squared take 4ac. So let us now employ this formula. The value of b is the coefficient of z, so negative 2 squared, minus 4 times the coefficient of z squared, times by the constant. This is the same as 4 take 12, which is really just negative 8. So if we get a discriminant that's less than 0, if our discriminant is less than 0, that means there are no solutions, which means I was correct. So what we can do to solve this equation is we can complete the square. So let us complete the square. To complete the square, we're first going to employ the b term. Okay, and if you forgot how to complete the square, I do have a separate video which you can watch. So that's z squared, take 2z, plus half of negative 2 squared. So half of negative 2 is negative 1, square that. Then we can do plus 3 equals to 0. But we can't just add this term just because we feel like it. So I'm going to add it to both sides. I'm going to add it to the left side as well as the right side. Now we can say these first 3 terms, they become a perfect square. So z take 1 whole squared, and the minus 3, well the 3, we can move it to the other side to become minus 3. And then minus 1 squared is just 1, so we can just add 1. So now we had z take 1 whole squared equals to negative 2. square both sides, or square root both sides. Z take 1 equals to the square root of negative 2. Okay, so that means it's the same as the square root of 2i. So that means that, or plus or minus, never ever forget the plus or the minus solution. And that means that z is the same as 1 plus or minus the square root of 2i. So two solutions are 1 plus square root of 2i, and the other is 1 minus square root of 2i. And that's how you solve this first question. The next one, okay, it's the same logic. We're going to use completing the square as well. So for this one here, we can say that we have z squared plus 3z plus half of 3 squared, so that's 3 over 2 whole squared, plus 3 equals to 0, but I can't just add this term, so I'm going to add it to both sides. Now we can factorize the first three terms as z plus 3 over 2 whole squared. Okay, and then we can move the 3 to the other side. So that's the same as 9 over 4 minus 3. And 9 over 4 minus 3 is really just the same as 9 over 4 minus 12 over 3, which is negative 3 over 4. Oh, sorry, negative 3 over, yeah, like this. So negative 3 over 4. Okay, now we can square root both sides. So z plus 3 on 2, that's the same as the square root of negative 3 all over 2. And the square root of negative 3 is really just the square root of 3i. Square root of 3i, and do not forget the plus or minus in front of the square root. So now we can solve this. Z is really just the same. We can minus 3 on 2 from both sides. That's the same as minus 3 plus or minus the square root of 2i, square root of 3i, all over 2. And that is the answer to this question here. Now the next question, we have a non-monic quadratic. So what do we do in this situation? We can just divide everything by 2. Okay, that's really not that big an issue. So now we can do z squared plus 5 on 2, z plus 2 equals 0. Let's solve this quadratic instead, using completing the square. So now what we can do is we could skip a step. We could just factorize all of this as z plus half of b, half the coefficient of b whole squared. So we could say z plus 5 over 4 whole squared plus 2 equals to 5 over 4 whole squared. Okay, so this is just shorthand. This is me skipping a step. So now what we have is we can move this 2 to the other side and evaluate the square. So this is the same as z plus 5 on 4 whole squared is equal to 25 over 16 minus 2. And this is really just the same as minus 32 over 16. So this becomes minus 7 over 16. Now we can square root both sides. 7 plus 5 on 4 is the same as the square root of 7i all over 4. Okay, plus or minus. And the reason I could do this so quickly is because I recognize, I'll just make it a little bit neater, is because I can recognize if I'm square rooting a negative number, it's the same as square rooting just the positive version, but then just adding an I next to it, because the square root of negative 1 is the same as I. So now our final answer is z equals to minus 5, plus or minus the square root of 7i all over 4. Okay, and we can get minus 5 by simply minusing this from both sides. So that's how you solve this equation here. Okay, let's do the next one even faster. So now we can do this one here. So to solve this one, we can just make it monic. So that's the same as z squared, take 3z plus 5 equals 0. So now we can use completing the square. So z take 3 over 2 whole squared plus 5 equals 2 minus 3 over 2 whole squared. Okay, this is just shorthand. Now we have z take 3 over 2 whole squared plus, in this case, equals to 9 over 4 minus 5. And 9 over 4 minus 5 is really just the same as minus 20 over 4. So 9 minus 20, that's the same as minus 11 over 4. Square rooting both sides, z take 3 on 2 equals to the square root of 11, I, all over 2. Because the square root of 4 is 2. And we also have to add plus or minus. So that means the final answer is z equals to 3 plus or minus the square root of 11i all over 2. And this is our answer. Now the last one, lucky last, we're going to solve a monic quadratic. Makes it very nice for us. So z squared minus 6z plus 14 equals 0. So now we can use completing the square. So this gives us z take 3 whole squared plus 14 equals to minus 3 whole squared. That means that z take 3 whole squared equals to minus 3 squared, which is just 9, minus 14 by moving this to the other side. 9 minus 14 is really just minus 5. So now we can square root. Z take 3 is equal to plus or minus the square root of 5. But of course, we have to add the I because we're square rooting a negative number. So that means Z equals to 3 plus or minus the square root of 5i. And this is how you use completing the square to solve a quadratic equation.